Hello, my name is Peter Schuck, otherwise known as Spinning Tops of Doom around the internet. It's how you can find me on Clojure, Slack, IRC, or on GitHub. Work for Bendyworks doing it as a software consultant, mainly working with Clojure and ClojureScript, Ruby and Rails, and JavaScript. And I'm here to help navigate everybody through ClojureScript's fire swamps. All of this is as of ClojureScript 1.9.494. And feel free to ask any questions that you have anytime during the talk. There's plenty of time for that. And it will help enlighten people in the audience and that are at home viewing this. So let's get started. That ClojureScript really seems inconceivable, especially to JavaScript developers coming into it. JavaScript developers see sub-second incremental compilation with hot code reloading and say, inconceivable. They see fully accurate source maps that are generated in sub-second times and say, inconceivable. And they see accurate advanced data code elimination and cross-module code motion and then say, inconceivable. And I think that word does not mean what they think it means. But of course, this is one step away from saying nothing can stop me now in terms of prideful boasting and hubris. So Nemesis is going to come and strike me down for all this so that we encounter our first ROUS that is not a function. And then we are going to spend hours or maybe even days trying to figure out a bug in our externs. So let's start our journey through ClojureScript's fire swamps. And first, let's pick up one of our assets in Google Clojure library, because when we're having fun storming a castle this imposing and foreboding, that we want all the assets we can get, not just a Holocaust cloak and a wheelbarrow. So I think that Google Clojure library is like a pretty comparable to like the standard library, batteries included libraries that you would see like Ruby or Python, that it is really full featured and it ships with ClojureScript, and you can use it the same way you would any other ClojureScript library namespace. You just use it in require inside of your namespace macro. And it is JavaScript code written for the Google Clojure compiler so that it will work really well with advanced optimizations. And it's a really great standard library except for the documentation, which is pretty much only written at like the API level. It seems to be written only for like IDE auto-completion and not really for any sort of end-user documentation. The source code, however, is written pretty well and is very readable, so that if you really want to understand what this particular portion of the Clojure library is doing, I would recommend going down through the source code. Do that. But you should really take like at least an hour or two to go through the Clojure library. There's really great buried gems. There's Ajax, both classic and using the new fetch API, that there's lots of asynchronous functionality that you can get debouncing, delays, and throttling in there. And there's whole swaths of methods for dealing with date, time, and time intervals, which are a developer's favorite things to deal with time. But it makes up for a lot of deficiencies that the JavaScript just doesn't cover. And one of the best namespaces that I would recommend that you look at is Goog Objects, which is just for interacting with JavaScript objects in a very safe and robust way. And if nothing else, you should really use GUI object get and GUI object set in place of aget and aset, which are just primitive accesses and modifiers for arrays. They really weren't written to do any sort of object interaction at all, and they're not really that safe or robust for, especially when you want to use advanced compilation. And Goog define is one really, really well-buried gem inside of Clojure library that you can use it to parameterize your builds. Like inside of here, you can call it with the Goog define macro. And right here, we're setting our timeout in our Ajax call to be 300 milliseconds. And that's just for development. And when we need to change it in our builds, then we can override that with the Clojure defines compiler option. And right here, we have to fully qualify the namespace of our symbol, and then we're setting the timeout to 5 seconds or 5,000 milliseconds instead of the 300 milliseconds. And we can use this to have feature flags in our ClojureScript builds with all the unused features getting compiled away through data code elimination in our production code. But there's like a few tricks that you have to do in order to get this dead code elimination. That for Boolean values, you have to type hint whenever you're using them. So that right here, when we're using admin, we have to type hint Boolean when we're comparing it with if to make sure that other code is dead code eliminated. And for string values, you will have to use either if or cond in order to get the dead code elimination. And you have to compare the strings using identical instead of the Clojure equals. Google Clojure doesn't understand the equals for dead code elimination, so you need to use identical to do the comparisons for string values. And now to probably one of the darkest and most dangerous portions of ClojureScript that I've ever seen, integrating it with external JavaScript. This is JavaScript that the Google Clojure compiler does not touch at all. And say we have this JavaScript library that has just a foo object that has one method bar, and that we call this library inside of ClojureScript. It's pretty simple. And everything is working really fine inside of development, and testing works just fine. QA works great. We build it and ship it to production. No errors in our compilation. And then we get an error in production where we see that see that our users now are getting this error of foo.w is not a function. And we look inside our compiled JavaScript, and we then see that it's just foo.w. And the question is, what happened to foo.bar that we called inside our ClojureScript? The answer is that Google Clojure renaming, that in advanced optimizations, that it will take the generated JavaScript of foo.bar and try to minimize that code size as much as possible, renaming foo.bar into foo.w. And so what we need to do is inform Google Clojure about all of the external names that we're going to use. And we do this through a file of external names or an externs file that we then write here saying, here's a foo object, and its function, its method bar has one parameter. And you can see all this extra annotation alongside the bar method that is not technically needed, but externs are much more than are preventing renaming, or that they also provide the Google Clojure compiler with a lot of information like type hinting and telling when functions are not going to have side effects that allow you to get the benefits of ClojureScript code, like dead code elimination and inlining that you could get from ClojureScript code for your externs as well. So with our externs now, we get the foo.bar function, we pass it to Google Clojure compiler, it reads its externs, sees that foo.bar is not allowed to rename. So the compiled JavaScript is just foo.bar, what we need to have that work. And so all we really need to do is to richly annotate all the APIs of all our JavaScript libraries. Yes, yes. Who here would really like to do that for all the JavaScript libraries? So unfortunately, this is the case for 95%, 99% of JavaScript libraries, that you're going to have to do all the manual work. There's nothing written for you at all. But there's a small portion of JavaScript libraries have had externs written for them. But you'll still need to manually load up the library and the externs inside of ClojureScript. And of course, the externs writer aren't the JavaScript library developers, so there will be corner cases of where they haven't covered the whole API or accidentally miswrote the externs, and that you'll have a very uncanny valley effect and many unhappy hours debugging if they did the externs wrong. But the best case scenario is if that someone has wrapped all the JavaScript and all the externs inside a ClojureScript wrapper. This is what cljs-oops does, so that you can call this JavaScript library just as you would a ClojureScript library and not have to worry about manually wiring everything up. But you can see that this takes 3 different sets of developers to synchronize and get all this to work. That you have the library writers themselves, the people that write the externs, and then the people that wrap up ClojureScript. Library inside of ClojureScript. And you have to repeat this for every single version of a JavaScript library. And JavaScript libraries stay very, very static, as we all know. So, This is why we like caught in the pit of despair and like only the most popular JavaScript libraries are readily usable. Is because the JavaScript community just changes very, very rapidly, and we need to synchronize all that externs and detail in order to get at this actually usable. So I'm happy to report that we can escape the pit of despair with two methods. We can use ClojureScript's externs inference or a library called cljs-oops. And externs inference was added to ClojureScript as of 1.9.456. And it can be turned on with the infer externs compiler option, which turns on the externs inference and also generates all the externs into a file of inferred_externs.js. And we tell then ClojureScript to yell at us when we're using inference wrong with the warn on infer option right there. And there are three types of inference warnings currently that we get. We get a warning if we're trying to use an unknown JavaScript object type. We get another warning if we're trying to use a method or property on the base JavaScript object type. And then we get a warning if we're trying to use a method or property that is not specified on an object that is specified in our externs, but is not actually, the method or property is not inside of our externs. So like for the first warning, say we have this cloudy function that we have an outside parameter, and we call getClouds on it. Then we'll get the warning of cannot infer target type for. And this is telling us that ClojureScript has no idea what outside is. It's an unknown type as far as it's concerned. So we need to tell it that this is actually going to be a weather type of outside. So what we do is we just type hint the outside with as a JavaScript weather type. And this is type hinting the similar vein of Clojure to get speedups. And the second warning is say that we get the result of the getClouds method and then call getType on that. Then we get the warning of adding extern to object for. And this is saying that we're adding getType to the base JavaScript object type. In other words, object.getType, which is not what we intended to do at all. And this is because, as far as I can tell, for ClojureScript externs inference, says that whenever we return something from a method, that's going to be the base JavaScript object type unless otherwise notified. So what we need to do is say that getClouds returns a clouds object, not a base JavaScript object type. So there's two ways to do this. We can wrap getClouds inside of a ClojureScript wrapper function and then type hint the return type of that function so that it is clouds, and then we can use this in place of directly calling the getClouds method on the object. And this will get compiled away during advanced optimizations, so you don't have to really worry that you're bloating your code size about this. The second way is that we need to add the return type of clouds to getClouds, and we need to then add clouds to our externs file. As you can see here, we're putting in the JS doc of returning clouds on getClouds and adding in the clouds and the getType function for getClouds for getType. And the final warning is say that instead of getType, we say we're going to call frog on clouds, and then we get the warning of cannot resolve property. And this is because we've told we have clouds in our externs with getType, but we don't have frog in our externs. So ClojureScript is saying, hey, this frog method, I have no idea where this is coming from. So either you have a typo inside of your ClojureScript code or a typo inside of your externs. You have to resolve this. So we can either change frog to the correct method of getType, or we can add frog into our externs. And those are how we can help ClojureScript externs inference write externs for us. And cljs-oops takes a different approach, saying we're going to sidestep externs inference altogether by using string names. And the idea is to use string names via Google object get or aget. That advanced compilation does not touch string names, so it just leaves it alone, and all compiling options work with string names. So in our cloudy function, instead of accessing getClouds directly, we're going to retrieve the getClouds method via GUI object get as a string name, dynamically call it with .call inside the outside object. And this looks like a lot of fun and brittle work for us to do just to get it to work with externs. So cljs-oops provides a lot of macros for automation. There's get, which you can retrieve properties from JavaScript objects, like right here. We're retrieving 500 square feet from our house's floor's living room. And then there's set, where we can set JavaScript object properties, like now we're setting our floor of our living room to be 300 square feet. And then call, which we can then call JavaScript object methods with fixed number of arguments. And right here, we're in the car, and we're playing I Spy, and we see I Spy a red barn, so that we can call it and get return the correct thing that we see. And then finally, there's apply, where we can call JavaScript object methods with a variadic number of arguments here. So we have the bill, and we want to total. Yep.
Can you go back one second?
Yep.
Does that work like in a nested way, call? Like if you have a nested object?
It does if you pass it a vector, I believe. You would have to go to the documentation for that. But I believe there is like 3 ways that you can call this. But I just did it with the simple string name. I believe if you pass it a vector, you should be able to call it with multiple nested arguments. Yeah, no problem. Right. And as you see here, we're totaling it up with a variable number of arguments, and we're getting 6 back as the result for our total. And cljs-oops is not just for automation, that it has a number of runtime and compile time validations, so that it makes sure that you're calling it correctly and that there's no typos, and that the objects exist, and that it will complain at you at the level of nesting that it finds an error at, and that once you turn on advanced compilation, it generates the same code that you would hand roll if you were using string names yourself. And this is also very useful for navigating JavaScript objects that you would get returned from a JSON API call. There's 2 access modifiers you can prefix your keys with. There's the question mark or soft operation access modifier, which will return nil if the key does not exist instead of having a runtime error. And the prefix of exclamation point or a punching access modifier, which will set a JavaScript object's key if it does not exist, instead of doing a runtime error. And I like to think of the question mark or soft access modifier as being like get in, where if we want to get our home's living room's color that does not exist, that we'll just get a nil value instead of having it have a runtime error, the same way that get in allows accessing nested keys for a hash map. And for the punching access modifier, that I like to think of it like a soch in, where if we want to set our house's living room's color to red on this empty JavaScript object, that will turn on all of those, that will create all of those keys and create the nested objects the same way that association will do for an empty ClojureScript hash map. And so these 2 methods allow us to quickly use external JavaScript libraries without having to go and write a whole bunch of annotations or type in all the externs files ourselves. But keep in mind that these only prevent renaming, that they provide absolutely no information to Google Clojure at all, so that this really hampers the use of advanced compilation. Basically, you're saying, just ignore these portions of my ClojureScript code, and so Google Clojure really can't do any sort of the optimizations that make ClojureScript really nice to use at all. So I would recommend to prefer cljs libraries or externs files where they are. They are much easier to work with and use, and they provide the Google Clojure compiler a lot of information so that you can get some really nice performance and code size gains at it. But when these exist and you really need to use that JavaScript library for your application, then I would recommend going through ClojureScript Externs Inference or cljs-oops. And now that we're gone through that very treacherous and dangerous fire swamp of ClojureScript, let's revive ourselves with a miracle pill because we're only mostly dead, not all the way dead. And let's talk about compiling node modules. This is as a ClojureScript master. It's not an actual version released yet as of today. And Google Clojure compiler can now compile our node modules. And we see really big benefits out of this, that Facebook React and React DOM ships 53K gzipped and minified. And with Google Clojure compiler, we can get that down to 32K gzipped and minified, about 40% savings in code size. So that's really great. And this is through a new compiler option called npm deps, where we just pass it a map of our libraries and their version numbers, and we just can use React and React DOM just like we would any other ClojureScript library. And also note that we are calling React and React DOM as namespaces, not as global JavaScript objects. So you want to use them like a ClojureScript namespaces as opposed to the cljs style of calling a method on a global JavaScript object. Just take note of that. And now for all the caveats, addendums, and little hoop jumping that we get to go through, because this is an alpha feature, so there's going to be many sharp edges. That ClojureScript does not manage the JavaScript dependency graph at all. So yes, you can see that ClojureScript can tell the ClojureScript libraries like Rainbow and Prism and manage their version conflicts just fine, but there's this shadowy netherworld of the JavaScript dependencies that they're trying to use, and ClojureScript cannot track or manage those version conflicts at all. So these libraries will just generate lots of bugs and errors since they're using very different versions of those two different libraries. And so what I recommend is if you are going to at all use npm deps and ship it as a library, that wrap it as the same style as cljs-js, that just do one node module and mark the version of your ClojureScript library as the same version as the JavaScript library, because otherwise there's really no way for ClojureScript to tell where the version conflicts are otherwise. But application development is the really big winner here, because if you're just importing all your node dependencies in your application, then you can manage them through npm or yarn instead of trying to have ClojureScript do what it was never meant to do at all, and that you can get to minimize your code size for your production application, because then Google Clojure can go through, traverse the graph, and find the common dependencies and minimize it that way. And now for all those fun hoops that we get to jump through. That first, we need to have a node module called module deps loaded. We can install it through either these commands through either npm or yarn. This is needed so that we can get all the files inside of node modules that our JavaScript dependencies need. And also that externs for node may be needed. And this is because a lot of JavaScript libraries nowadays use node to compile to their final production version of JavaScript. And they use some internals of node, like React uses process.m.nodeenv in order to tell if it's compiling to production or to development. And all these externs are available at this URL. And finally, we'll need cljs libraries for externs still. And this is due to the fact that many JavaScript libraries will dynamically export their names through metaprogramming, and the Google Clojure compiler does just static analysis and static inference. So all those dynamically and metaprogrammatically generated names are not visible to Google Clojure. So the externs tell Google Clojure that these names are going to be used in this JavaScript library, but even if you can't see them. So those are all the hoops that we get to jump through. And now I'm going to go through how to make the miracle pill from scratch, because this is, again, alpha level feature. So there's going to be found sharp edges and bugs that you're going to encounter. So this will be very useful when you're debugging about how the actual steps that we go through in order to generate these npm dependents, compile these node modules. And the first step is, as wise person once said, first to create a miracle pill, we need to create the universe or install the universe. We need to install React and React DOM either through npm or yarn. You can do it through these commands. And also note that we need to lock down the version with the little @ sign saying it's that particular version of React and React DOM. And And then next, we need to create the recipe for a miracle pill. And this is done through a root JavaScript foreign lib, where we set up all of our dependencies and our exports. See here that we're requiring React and requiring React DOM, and then we're exporting React and React DOM. And then we need to collect the ingredients for a miracle pill. And this is done by passing our root foreign lib into cljs Clojure node inputs. And we just specify where our root foreign lib is located, that here's the namespace, and that it's a common JS module, and then pass that into node inputs. And then finally, we're ready to create the miracle pill that we have to take the result of node inputs and pass that into the foreign libs compiler option of our build. And then we get exactly the same result as npm deps. That the only difference is that React and React DOM are inside of are on the root namespace of lib.npm deps instead of being their own separate namespaces, and that's pretty much like the only difference. And this is like still very, very alpha, but it's not just like ClojureScript developers that are pushing this and working on this. That major players are working on integrating Google Clojure. That React through its Fiber build system is working on this. That Angular through its offline template compilation is also working on this. And TypeScript is working on TS-ICL, a compiler that compiles TypeScript code to Google Clojure compatible code. And now that we've gone through the external JavaScript libraries and node modules, let's take a nice relaxing tour through the fire swamp of dynamically loading ClojureScript modules. That ClojureScript modules are fairly straightforward to use. They've been around for like 2 years now at least. And we just like say, here's the module name, and here's all the namespaces that we want inside of our module. And Google Clojure does like the majority of the hard work, and cross-module code motion makes it so that we get good code splits like right out of the box. And we may have to do a little bit of work to get them optimal, but right off the bat, they are pretty good. But dynamically loading ClojureScript modules is a very big, massive, object-oriented boilerplate. That we get all this module management object-oriented style, where we have to first instantiate a global singleton module manager. Then we set the loader on the module manager. Then we have to set our module dependencies and also the URIs on the module manager. Do that. Then we get to go throughout all of our modules and call this setLoaded function to mark it as this module has actually been loaded once it's called. And that's just all the module management bookkeeping. We're not even to loading our modules at all. So here is the desired end result that we want out of the end of this, that we have our root module, and we just call a function load module that loads our extra module and then fires this callback once the module has been loaded. And the tricky part is that for development, which is when we have no optimizations, that the modules is not available, that we can't do the module code splitting there, and also that development loads all of ClojureScript namespaces automatically, so that we have to do a few extra steps in order to get this working for development. That first we have to put all of our modules inside of preloads, and this is the fact that we don't want that the only other way to get our modules to load correctly inside development is to put them inside of our root namespace and not ever use them, which does not really strike me as a clean code. That we want all of our module dependencies to live in our build, not inside of our actual code. And then, yeah, you can ignore all this fun stuff. That's just a working model of a working code example of how to do this. But this is how you load modules in development, that they're automatically loaded. So every 100 milliseconds, we'll just go and do another query of, is the module loaded? And then fire off the callback if the module has been loaded. And for loading modules in production, it's much simpler. Much less code. That all you have to do is call the execute on load from the module manager. You're all done. Then we have to tie this all in a nice, pretty bow. We have to say which module loader we're going to use. Are we going to use production, or are we going to use development? So with that, we use Clojure defines there. Told you it was a very good buried gem. And then switch it out so that we compile away the unused module loader. And I think it would be really nice if someone would create a ClojureScript library to handle all of this. In fact, I did. It's called Element Modules. It currently removes about 50% of the boilerplate that is around there, and it's available at GitHub under Bendyworks and conweb-modules if you want to go look at it. And so we've gone through all the fire swamps of ClojureScript, and we come back out alive. We should feel very proud of ourselves. And I just want to say before I give my thanks that people, when they think of ClojureScript, really only see one Dread Pirate Roberts. And I really want to say that there are many Dread Pirate Roberts in ClojureScript, that there are many people that make it the warm, welcoming community, the great language, and the nice ecosystem that it is to use. I'd like to give thanks to Antonian Hillebrand for helping me understand cljs-oops and externs in general. I'd like to thank Antonio Martino for helping me with my presentation, and also for helping me understand compiling node modules. I'd like to thank David Nolan for helping me with this presentation and understanding some of the darker corners of ClojureScript. I'd like to thank Alan Ronher, I hope that's how I pronounce the name, for his blog post on dynamic module, ClojureScript module loading, since that's where I got 90% of my information from. And finally, I'd like to thank Martin Klepsch for his parameterizing ClojureScript builds blog post, where I got the majority of my GUG define information from. And finally, that steal this presentation, I put this in the public domain so you can use any of these examples. I really want these features to be used and well documented inside of ClojureScript, so feel free to grab any of my examples or things in this talk. And any questions?